Hello all. As promised, I am doing a short video tutorial on fatty acid biosynthesis. Now recall in lecture that we went over this pathway that I'm showing here, and we ended up with a fatty acid chain of pretty limited length. And as we discussed, there are lots of reasons that cells need longer fatty acid chains. And the way that they do that is they take this intermediate right here at the end and they use it in place of acetyl-ACP. So notice that we've got acetyl-ACP over here, and really the only difference between acetyl-ACP and this intermediate is that this intermediate has a couple of extra hydrocarbons on it. So what I'm going to do is I'm going to draw the second half of the pathway starting right here, except instead of using acetyl-ACP, I'm going to use this intermediate in its stead to demonstrate how cells can use the same basic pathway to build longer and longer fatty acid chains. Okay, so let's start out with our intermediate that looks like acetyl-ACP except has the longer chain. So notice that I'm going to keep the colors consistent from last time so that we can continue to keep track of where our carbons are coming from. So let's just start out here with our CH3, CH2, and then again we're keeping track of our carbons, so we'll switch colors. And then we'll keep our ACP in orange, just like we did previously. Okay, so there is our intermediate that we're using in place of acetyl-ACP. Now our other intermediate, malonyl-ACP, is exactly the same as previously. So I'm going to use the same color scheme for kind of the extra bits, and then we'll use a new color for the carbons to indicate that now we've got new carbons being introduced. So let's draw that out. And we'll have this new malonyl ACP, and it is a new one. We've used the carbons in blue already. They're right here. So we grab a brand new malonyl ACP that has been through the first part of the pathway, and we will indicate the carbons from this one in green. And again, we'll put our ACP in orange. So the rest of the pathway really is exactly the same as previously. You have these two components coming together, and an ACP is kicked off, and a CO2 is kicked off. And the difference is, again, simply that we have this longer chain. And I'll draw that out so that you can see where the carbons for this longer chain are originating. So here are our purple carbons. And now our blue ones. And now, since these two intermediates have been combined, we will draw our chain, our carbons, our new carbons that we've added to the growing chain in green. So here is our intermediate, and this goes through the pathway exactly as we showed previously. So there are several steps in the pathway, and you use two NAD pHs. So NAD pHs donate their electrons, and water is kicked off. I won't draw that. Well, yes, I'll go ahead and draw that. Let's make it complete. So here we have an two NAD pHs, and they are donating their electrons. So you get an NADP plus. Water is kicked off, and so you get a new intermediate. And once again, we're keeping track of carbons. Now, if the cell decides that it wants to build an even longer chain, this intermediate right here would go through the entire cycle again, but in place of this intermediate, this one would be used. Now, if the cell decided that this is as long a chain as it needs, it would go through the final step where ACP is kicked off. And you would end up with the following. So that concludes the tutorial on fatty acid biosynthesis.